just how hard it is to find in a busy graduate student schedule a well-matched TA or GA position, because that's got a lot of potential, right? That's just, the problem you're solving is time, right? Efficiency. Yeah, and maybe you make it research focused, maybe it's only for TA, GA positions and research focused, and it's not just every class. I mean, you could narrow it as much as you want, but cool idea. I think pretty solid first pitch-ish. So thanks for getting up. All right. Looks like Garrett's gonna make it. He has 2 minutes. So $100. I'm gonna go with I gotta think through who. I'm gonna go with the plastic. I like plastic for that. Does Josh usually have a Chris Bundy to hand you?
No, he normally just pulls out a Chris Bundy, like NGO.
Yeah. Yeah.
I don't know if you're allowed to give out his money.
I don't have his money, but we'll make sure you get your money.
Okay.
But he told me I could give it out.
Okay.
Yeah, man. Congratulations.
Right,
I like this plastic idea. And your pitch, what I liked about it, totally under 2 minutes, really crystal clear, right? So, great job.
Thank you.
Don't spend it all in one place. All right, Garrett is probably in the building. What do you want to do? Do you have any admin stuff you want to take care of? Yeah. No. Okay. Okay, cool. So we're just gonna do a couple of admin details. JD Ross is coming in from Open Door next week. That's a good one. What else do you have? You guys know typical communication, TA at Slack community, class rules, no secrets. Class rules, no secrets. That's me. All right, Garrett. So Garrett is the CEO of Pipe Dreams, and I'll do the intro while he's getting in here. But I just learned about this company, and as I understand it, and we're going to ask him about the details. It's like, does anybody know this company already? Tell me what they do.
They take utility pipes and stuff robots in them that drive food to your house.
Okay, utility pipe stuff robots in them. Anybody have anything to add?
They do this using existing infrastructure and
Existing infrastructure?
like generally existing infrastructure creation process. So they don't have to go through. They don't have to get cities very on board or change the process that cities go through to like add infrastructure providers. They can like rely on the existing policy.
Well, look at that, the man himself. The man, the myth, the legend. Garrett Let me grab these chairs here and we'll cruise them over. Well, welcome. Thanks for rushing over.
Yeah, no worries. Thanks for waiting on me. Sorry to be late, everybody.
You know, it worked out. We did open pitch pizza, and then I got to ask the students, do you know what he's doing? And they have their version, and so now we're going to talk about your version.
My version changes.
All right, let's give this man a mic.
Awesome. I was so bummed I missed the open pitches. What were some of the the one-liners and some of the pitches?
Well, the one that won is he got $100, and he is making a plastic that degrades in 1 year instead of 400 years, and we like the idea of that.
Yeah, that's a solid pitch.
Yeah. That's a solid
400x improvement.
Yeah, so Garrett, let's start. Give us your academic background, just because we're a student-based class. We should know where'd you go, what'd you graduate in?
Totally. I am going to give some Google Drive access. Did you get it?
Yeah.
Oh, perfect. That looks like that's definitely the first slide. I'm sure. Yeah, perfect. So my academic background, I was a mechanical engineering major. Realized like halfway through mechanical engineering that I was totally wrong. I had always had this idea that, you know, I wanted to build stuff and sell stuff, and so I thought, oh, I need to go learn how to build stuff, and like the selling will come super easily. And then halfway through engineering, I was like, oh, you know, actually the hard part is selling it, like building a business model around innovation. I need to learn that. So I finished out my degree, you know, mostly for my parents, and then just decided I'm not going to get a mechanical engineering job, and like I need to just go learn business by doing it. So that's what I've been doing since.
I know you've got some slides, so if this is in there, fine, but I was just kind of queuing up some context before you hit it. So what was your first job out of school?
I didn't get one.
Okay.
Yeah, I had like a $600 apartment and like $200 over their expenses. And I was like, all right, I'm just going to try to figure out how to make $800 a month. And it's kind of like trying to, I don't even know if this is true, but it's the analogy of when you push a bird out of a nest, it's going to learn to fly on the way down because it has to. So this is kind of my version of like, okay, if I have to make it better.
And splats.
Yeah, totally. So this is probably why we see a lot of birds who know how to fly.
Yeah.
But I didn't splat, almost did. But it's just like my way of like putting my back against the wall and like forcing myself like, okay, you know, go learn how to just make money, learn sales. So the idea was like build a service or a product. I learned to code a little bit that made money, hit it at $800 a month. So that's what I did right out of college.
So you got the degree for your parents, but is there anything about your degree that you use today?
Oh, definitely. Yeah, we're big. I think engineering, just any type of engineering, teaches you really good problem solving skills. And so we you know, a lot of the team are engineers right now. And so even if they're not in an engineering job, they have the engineering background. The engineering background is so good for problem solving and asking yourself like, okay, what are the real variables of this problem? You know, we call it thinking from first principles. Like, what are we really trying to solve with this? Like that part of engineering, I'm so glad I went through. That was huge. The math, I could have probably done without.
Yeah, I definitely could have done without the FEQ.
Yeah, totally. I have like a PTSD response during the day.
I did too, because I got a biology degree, and here I am, you know, 30 years later, teaching students who are scientists. A lot of my grad students are masters and PhDs in STEM-based programs, and a lot of them are like, well, I'm not going to go do tenured academia. How do I go to private sector after I got a PhD in chemistry or math? And you know, I remind them that so much of entrepreneurship is the scientific principle. It's the form a hypothesis, test, iterate, right? Test, iterate, until you have enough data that you can substantiate what you're doing. So anybody out there contemplating quitting your degree to start your company, Josh is always like, he encourages people. I'm like, get your degree. I'm one of those people. Anyway, do you want to go into slides?
Whatever.
Did you have slides?
Yeah, I have some slides, but if everyone already has like a little bit of background.
I don't think we do. Well, here's what we know.
Yeah.
You put robots into pipes and move shit.
Yeah. No, that's it. Forget the slides. We can run through the slides real quick.
Let's do that.
Quick
And
overview.
then we'll go back to conversation
Awesome.
after that.
Should I hop up?
Yeah, I think they've got it queued up for you.
All right, sweet. No, thank you so much for helping me out. I really appreciate it. You were the MVP. So I've had a bit of a crazy 72 hours. I was in Las Vegas up to like 18 hours ago. I was speaking at a conference there. It was called Grocery Shop. If you love grocery, it was like your Super Bowl, and for everyone else, it was like the worst conference ever. So I loved it, but it was like super niche-y and nerdy. So we were there, and we had to go to Atlanta for our pilot and check something out before we came here. And so the only flight out was a red eye at 11 that left Las Vegas at 11 and got into Atlanta at 6 a.m. We had like 3 hours, and me and my co-founder had never gambled before. And we're like, okay, we gotta just do it once. So we took $20, and this is maybe not a great story. So we took $20, we're like, all right, we're just gonna take $20 and just like play the slots one time. We 10x'd it in like 3 spins. And we're like, this is the worst lesson to learn. Like, this is how gambling addictions start. Like, we got this hot hand, we 10x, like we feel unstoppable. So we have to continue this until we just lose. So the idea was, we had 3 hours to the flight. There were like, the people told us there were like 550 slot machines. And the goal was, before our flight, we should play each one time. And so we just like laid out a map, and we're like, okay, so this is the system, like, can we play? And so we were just kind of like just popping in, hitting, popping it out, like minimum bets all the way around. And we lost a good bit of that $200. Not a very, the house always wins on that one. So we did that. Yeah, that's what we left with. I think we left with like 180 and just started handing it out to people. So we made it to Atlanta. Those are the clothes that I'm currently in. I crawled in to check something out. So I don't know how dirty I still am, but I was pretty dirty at that point. So that's where the dish shovel look comes from. And then, oh, you know, you figure it out. You know, it's tough the first time, and then you kind of get this caterpillar motion through your shoulders. That's not bad. At some point, we're gonna do a race down the length of it, but not yet. And then yeah, I hopped on a plane, and the plane got delayed, and then I pretty much just sprinted straight from there to here, and that brings me here. So I'm so sorry for being a little late, a little disheveled, haven't slept in 48 hours. We're here, that's the game. So what we're doing at Pipe Dream is our long-term vision is to make 30-second delivery times happen, and it's really, we set out, you know, I was talking about right after college, I just went and started building stuff, which was fine. I learned business, but it wasn't like, they weren't great things. They were just fine things. They were like package management for apartments. Like, yeah, you're gonna get like, you know, some X monthly subscriptions, and it's fine, and it's like, okay. And so I learned all this stuff on how to build stuff, but it wasn't like, it didn't inspire me at all. It wasn't like a big bet, and so I was like, okay, in my 20s, I gotta take a big bet, so I'm gonna take 2 years off and just diligence, like what is gonna be that 10-year bet I work on for the next 10 years of our life. So we looked at a lot of industries, landed on last mile logistics, and the idea was like, okay, where's last mile logistics headed? Like, what is that next step for last mile? And I think if you guys listened to the podcast, I think Josh sent out, like the idea of hyper logistics is really what we landed on, is like this theorized state that like logistics professors nerd out about, but it's like way too far away to be possible. But the goal is to make that possible this decade. And the interesting thing about hyper logistics is not only do you have those really fast delivery times, you also have the ability to send things back really easily. So every receiving mailbox is sending back mailbox. And just like the things you can do with that are crazy. You know, the analogy is really similar to, oh, did I lose it? Am I too loud for it?
No, I think it's Jack.
Okay, is that better?
Yeah.
Nice. Yeah, similar to the internet, where like you stored all these files on your computer because like the download times from the internet were super long, so you'd like buy a movie, you download it, it takes super long, it ended up in your computer. You're like, all right, because I bought this movie and it's gonna take super long to download again, I'll just leave it on my hard drive. That was like late 90s internet. But as download speeds and upload speeds got faster, we don't do it anymore. Like, we don't store files on our computer. Like, maybe we'll pull it down, use it, and then just like dump it or send it back. And now we don't like have all this stuff on our hard drive. Very similar to how we like won't have stuff in our homes as delivery speeds and sending back speeds get faster. It'll be much more of like a renting economy than an ownership economy. Which is just like, that was like, okay, we can live with trying to make that work for 10 years and fail. And as long as like we gave it like a really good shot, and maybe something that we did help someone else figure it out, like that is 10 years well spent. So we locked in, we said, okay, that's the thing we're gonna do for 10 years. We're not gonna give up until we figure it out. I quit my job. I was doing biz dev at a startup, prosthetic startup in Oklahoma. I quit my job. I had like a certain amount of months runway, and we just like started doing it, and another like jump out of the airplane without a parachute moment. And we built it on the way down so far, so could still hit the ground. So what we landed on is really what's missing from the last mile ecosystem to make hyperlogistics possible, is a really high volume, high speed, high safety delivery system. So we initially started with drones. Drones was like where my expertise was. My co-founder's expertise was as well. But we realized that the business model for that is super tough. And that in order to get to hyperlogistics, drones were going to need a ground-based counterpart that could match them in speed, and also solve like that first inch and last inch problem. So how do you get from in a building to out of a building and out of a building back into a building? And we were like racked our heads like, okay, what could do that? Like sidewalk robots are too slow, self-driving cars are too big. And just like racked our heads against the wall and then realized like, oh, cities already solved this distribution problem. They do it with these small underground pipes. Could we use those underground pipes for commerce? And after a little bit of a diligence process there, because we're like, okay, that seems like way too hard. But then realized that, oh, this is actually really doable and actually pretty scalable. So that's what we're doing is we use just standard utility pipes. This is the standard ones. You can kind of see it. Okay, well, ignore me. That turned out to be a way dorkier picture than I remembered it. I felt so cool when I took it. That's pretty tough. So ignore me in the middle. But that's just a standard utility pipe. So it's something that cities are really used to putting underground. The construction crew who's putting this underground has several other projects happening in that city. And then the city grants permits for this type of utility pipe in 2 weeks. So it's a really quick thing to get through government permitting. Oh, wrong way. So the way that you turn those pipes into delivery networks is you have to put all the technology in the bot. And I think this is where underground logistics has failed in the past is the knee-jerk reaction is put all the tech into the pipe, make the pipe like pneumatic or some other type of propulsion. But that just creates so much cost on the infrastructure side. And then really the game here is how cheap can you put it in? Because once you have that infrastructure in, all the other costs kind of go to zero. It doesn't really matter. So we put all the technology into this bot. This is a render. We have a not so nice version of this at the lab. But the goal right now is by next summer to build out the first middle mile network in a city. So you kind of think of it as like a subway system for things. Middle mile is something that on a nationwide scale, that's how logistics works. It's like the most optimal form of logistics where you can take one of these nodes and do a bunch of pickups around it, drop it off at the center, that distributes out to wherever it's going, and then someone on the other side picks it up and can deliver it. The efficiencies of scale on that network for nationwide deliveries are crazy, but there's never been a system fast enough and fluid enough to make that work on the city level. So that's what we're trying to do here. It's one of those like holy grail logistics systems that if you make it works really well, but it's pretty tough to pull off. So yeah, kind of went over that. So our roadmap right now is the pilot is going to finish in like the next couple months. That's where we went out to Atlanta to check. And then our number one goal is to make the first citywide network happen by next summer. And there's pictures of the pilot. So we are going from inside an office building about almost a mile out to a shopping center where we'll operate like a micro fulfillment center, and then also there's a whole bunch of convenience stores and restaurants around there that we'll plug into as well. So it's essentially free delivery to everyone at that office park. I think there's like 600 people who work at the office park. So we're testing two things there. It's just like, okay, can we do this at scale? What are the problems doing this at scale? And then also like, what happens to customer demand when you take delivery cost to zero? So that's going to get going by the end of the year, and then our full focus will be getting the network done. So I think I'll pause there. Definitely sped through it, but I know we want to have time for questions. So.
Yeah, I have a ton of questions. Okay. One just quick clarification. You said it's about a 2-week permitting process.
Mm-hmm.
Is that for pipe dream to get permitted to put your pipes in the ground, and you abandon the notion of using city infrastructure that already exists? Or
that's I think that's a confusing thing about just how I pitch it. So when we say utility pipes, this is a standard utility pipe material. So that's like cities all use this type of HDPE 18-inch pipe, but it's not actually repurposing. We have to put in a new.
So they're dedicated pipe for
dedicated pipes. Yeah. We could probably reuse, but it would almost be as much trouble to like try to figure out how to reuse as it is just to put in our own.
Yeah, because if I'm not mistaken, and I may have the specifics off, but that's how the original fiber optic networks got built, right? Is they took old abandoned oil and gas lines, and I believe it was Ross Perot's company
Yeah.
that did that.
Oh yeah. Yeah, the nice thing about fiber optic is pretty small cable, you kind of like thread it in places. So a little different problem here. I think we could, we're kind of treating that as like an icing on the cake thing, where if we run into those and it works with the current network as opponents, like, oh, that's cheap. But pretty tough to find those. Yeah.
So what are the attributes of, like, how do you know where you should put pipe first? Because it's an endless sea of opportunity. And through all the pitches, I was like, narrow your go-to-market strategy, narrow what you're talking about. So like, what made you pick Peachtree Corners in Georgia?
Yeah. So the reason that we picked Peachtree was it was something that we could execute really quickly. We had gone through the permitting process. The office park allowed us to go in, and the shopping center allowed us to go in. So it was like, it satisfied all the requirements that we needed from a demo. So on that side, we just did the fastest thing we possibly could do.
Are you from Atlanta?
No.
So how
I've
did you
never
pick
been.
Atlanta?
So.
I mean, surely there's 0.75 miles between office buildings and grocery store, restaurant epicenters all over the place.
Yeah, it's pretty, working with cities is like a pretty opaque process. And so at the time when we hit go on that, it was a little gray how the permitting process works and how quickly you could go through it. So for us, it's like, okay, let's just go through it once. We know that Peachtree Corners, it's a suburb of Atlanta, is a place that's known for speed and that we can get through that process really quickly. So let's just go do that really fast, because we definitely have, as you're looking at like building out this system, this is kind of our holy grail of we need delivery volume on this system. That is the number one KPI that we have in the company. And when we go to companies and we say, hey, we're building out these networks in cities, and this is actually a picture of our simulator. So we have a network simulator where you can drop these nodes on a map, and the network self-generates and gives you like an idea of like how useful that network would be to city logistics. So we can go to people and show them this model, and they're like, yeah, but you're never gonna, like, yeah, if you do it, we'll use it. So I call it it's our ticket to Mars problem. Like if I went up to you and said like, hey, I'm creating a Mars travel company, and would you like to buy a ticket to Mars? You'd probably be like, yeah, I'd buy a ticket to Mars if you ever made that work. And then if we were like, oh, hey, the rocket's ready, like it's leaving in a couple months, like you said you wanted to buy a ticket, you want to buy the ticket, you're like, oh, okay, well, hold up, I have a family here and like I have all these other problems. So when we go to companies, it's like, they definitely are like, yeah, we're definitely gonna use it, like just as soon as you get it built, and it's like, we need to just build it, make it real, make it, start testing on it, and actually figure out which of those sales we can actually close and which ones are like separate from a ticket to Mars problem.
Yeah, I mean, I feel like you just need one from Chick-fil-A down Speedway
Oh yeah.
through the center of campus.
Yeah, totally.
I think that's pretty damn good. You could call it the Chicken Express.
Oh, there you go.
Yeah, but I think that's what I'm looking for, is like, it's such a cool idea.
Mhm.
And it's a big ocean to boil. How do you go from just sort of like super high level to, we're gonna look for things with these attributes that are
Mhm.
repeatable and scalable, and
Yep.
you know, clearly you're being very systematic about how you're thinking through and exploring and testing and iterating.
Yeah, I would say like we're still through that idea maze. We always say like we hold our paradigms, like a paradigm is like fundamental truth. Like we hold our fundamental truths super closely and not very tightly, right? So you want to like have this idea of like where you're going and be like full steam ahead going towards it, and as soon as it's invalidated, you get rid of it. And so it keeps us like really loose, and sometimes it's like, especially when you have like these really hard problems with a lot of variables, you just get paralyzed. It's like, okay, I don't know where to go, and so you just kind of like cease motion.
Yeah.
Whereas continuing motion and continuing down a plan, knowing that it's probably wrong, you learn so much going down that. So that's kind of where we've been. I don't know if it's right. We've definitely made some mistakes. But when we look at these networks, we have We've defined it by like 3 properties. So we call it, this is our, you guys know like the idea of like a minimum viable product, right? Like it's the minimum thing that you can get out and solve a problem. So we call this the MVN, which is the minimum viable network. So it has 3 attributes. Attribute number 1 is a 5-year ROI. That's a really aggressive ROI for infrastructure. But the idea is like we should shoot towards something that doesn't rely on current infrastructure financing rails. It should be better, because if we can find something better, we're going to be golden. So 5-year ROI. 2, it needs a certain amount of delivery volume to hit that ROI. So you need make sure you have that delivery volume. And 3, it needs to be scalable. So a lot of the times advisors, and they could be right, but a lot of times advisors will be like, oh, just go build something out between like a hospital and a medical center. That's like a really high value interaction. You can go back and forth. The problem with that is we want to build a real like fundamental logistics company, and if we're putting all that capex into one one-to-one network, then if you add a 3rd node onto that network, you're just connected to like a medical fulfillment center and a hospital. Like, how valuable is that 3rd node, right? So as we think about building out this network, we want to build it big enough and spread out enough in a city that as you add nodes, you're turning on exponentially more customers. So not only are you, if you have like this area here, right, you have, call it 60,000 addressable users, and you also have, no idea, I'm gonna call it like 400 origination points, so like grocery stores, restaurants, convenience stores. If you add a node here, you're giving this convenience store access to that pre-existing 60,000 deliverable market, and then you're also giving this 60,000 deliverable market access to those stores and those restaurants at those reduced costs. So that is our current plan. Is we want to do something that is scalable, not just like a really interesting use case for one person.
So is
That
the
could be
idea
wrong,
that
though.
like the convenience store up there in the northwest corner has now unlocked the ability to get a stick of gum to somebody on the southeast corner?
Totally.
So you're gonna have consolidation of the market in small products, right? Because right now, the location is why they exist.
Yeah, I think if you look at 15-minute grocery and GoPuff, like they have this delivery model that's really caught on, right? Like there's a lot of demand for.
I'm not familiar with it.
Oh, GoPuff?
No.
Anyone familiar with GoPuff? Awesome. Why right here? Why do you like GoPuff?
Me?
Yeah.
Because you stuff quickly that I want.
Yeah.
Yeah.
It's a super interesting business. So the idea of GoPuff, I think they started as like, I think it was called GoPuff because it was like a stoner app. It was like, oh, if you're stoned and you need snacks and you can't drive, like we'll deliver you snacks. But it really caught on in that there were like these items that people wanted, but they didn't want to leave their house to go get them. So these, if you talk to convenience stores, like they're really scared of the delivery problem. So like GoPuff can take these fulfillment centers and go in and do these deliveries to doors and beat the convenience stores that are like already near the person but not at their door. Being a delivery first organization, the problem with that, like it's great. There's like this, especially from younger users, like there's this a lot of consumer demand for those products. And I don't know if you guys familiar with like the 15-minute grocery trend in New York. It's big in like LATAM and Europe. Yeah, it's the usage rates were off the charts, but it's like with the current cost of delivery, it's impractical, and so they all died. So I think they ate like $3 billion in VC dollars in like a year between all of them. It was like Joker and Gorillas and Fridge No More. And a few others. They said they still exist in like LATAM in Europe where there's like more walkable cities. But all these convenience stores have the opportunity to be GoPuff. GoPuff exists out here, and that delivery model is unsustainable, right? They have the same Cherry Garcia as everybody else. It's like the same Ben and Jerry's pint. but because they're able to subsidize their delivery, they beat the convenience store. But whereas you can get, you know, a network like this to cut those delivery costs, then, you know, the GoPuff are out here, the convenience store out here, they all have, you know, cheap distribution to those endpoints that exist on the other places.
I love how you're thinking about it. Let's open the conversation to the class. There's so many directions we could go.
Yeah.
We used to start in the front as a thank you for sitting in the front. So we'll start from the front and go to the back.
Sweet.
I wanted to ask you, so I'm looking at a
Just
map.
pass it around to each other.
So I'm looking at a map of Austin right now. First of all, is this part of your future plans for expanding?
Oh, this network's not. No, it was just one that I grabbed. I think this one's actually been invalidated as like this isn't a well-distributed node system. But yeah, it's like a version of this in Austin would be awesome.
I was gonna ask, yeah, like, is that one of the things you take into consideration is like walking areas versus driving areas?
So right now we've I don't think if you're ordering delivery, you expect a two-door experience. If you had to go walk to like a pickup location, you might as well just like walk to like wherever you're getting something delivered from, or like go and just like extend that walk. It's like the effort to leave your house or your dorm is so big, like wherever you're going after that doesn't really matter. So when we delivered one of these endpoints, there's still someone who's finishing out that delivery from that node. So really when we look for node locations, it's really how accessible are they by car, and like how cheap is it to get that real estate to put in that node.
Okay.
Kind of like an Amazon Locker.
Oh, okay. So do you also see that becoming like an accessible type of job just for people in the area? Like you could sort of freelance that?
Oh yeah, totally. So Justin Robinson, who co-founded, you guys know Drizzly? It's like an alcohol delivery company. He sold it to Uber last year, but he runs our partnerships and strategy on the delivery side. And so we'll use a similar model to Drizzly where they own some of their drivers, and then they also contract it out through like, there's just so many like freelance gig driver apps. So yeah, we'll do one of those.
Thank you.
Yeah.
All right, second row and then third row. But we'll do one on this row and then that row and then that row. Go for it. No, the ones in front.
Thank you. All right, so what did the process of iterating from first drones and then realizing, oh, this is not a feasible business model, and then going to underground pipes, what did it look like? And did you bring in any experts related to, urban city planning to talk to about this business model? What did that process look like?
Yeah. Drones, I do think drones are a feasible business model. I do think they're actually a great business model. It was just one very congested space, so it would have been tough for us to win in, and then also like getting to that next stage of hyperlogistics just required that ground base. So we saw more blue ocean space going underground than we did like competing. I think drones essentially are, they're an accelerometer and four servos and someone who's promising safety and an FAA accreditation. Like there's not much to them, so I think eventually they become a commodity, and the people who already have the order gen, they're the ones who are going to win the drone space. So it's tough to be a manufacturer, or even come in without that pre-built-in order gen. So I do think drones are a viable business. And then when we talked to, as we started thinking through, okay, underground doesn't make sense. There were really like four things when we said like doesn't make sense, right? You have, do robots throwing through pipes make sense? Can you get these networks permitted with the city, right? What does that process look like? There was, we had four really good ones. I don't know, it's the logistics problem. Is this like a problem for businesses both on the 3PL side, so UPS, FedEx, and then also on like the food delivery and convenience delivery, like that kind of is something that fits within the 1 hour delivery window. So we went around to all of them. It was like a 3-month diligence process, And the robot one, we can kind of validate ourselves. We have that experience ourselves. We talk to a lot of city people. You really have to be, I think you have to be careful. Anytime you're getting advice from someone, you're asking an expert, the amount that someone has like a personal bias or pessimism or even optimism, like either one, so infects their advice that we try to get like at least 5 opinions and just kind of like find the common center of all of them, right? Because it's very, very, very tough to diligence advice like that. So we definitely did talk to a lot of experts, but you kind of like find it's more like pulling on a thread than just like accepting their advice carte blanche.
Thank you. My last question was, how did you find other people who like you were like, okay, let's work on this project for 10 years, we see long-term potential, we're gonna just focus on this and see if it works out for 10 years?
Yeah, that's probably the tougher one. So we have a hiring rule, because it's like doing stuff early on, you realize that like the people that you work with make or break. It's almost like what you're doing doesn't matter. The product is the team, right? If you can get a really good team who's really good at what they do, what you guys are doing doesn't matter because you'll find the right thing. So we over-optimized for that. So we had a hiring rule where the idea was kind of borrowed from Amazon. For the first 10 people, you want to bring on the next person. You want to make sure that they're so good that they kind of make everyone else that you previously hired and you yourself look like an idiot. Like, you're like, why is that person here? They're so good. These other people don't hold a candle. So it made the first hire super hard. I think we interviewed, it had to have been 50s, like maybe close to 100, somewhere in there, people before they found the right person. And I think really like most of our great hires have come from social media. Which is something that I never wanted to do. I'm kind of like a builder. I like to hide in the garage, in the cave, and like never tell anyone what I'm doing. But we did a better job this time, last couple of years, of doing more, talking about what we're doing. And when you talk about what you're doing, you just create like this lighthouse for these serendipitous people would be like, oh my gosh, I love what they're doing. I would love to go work with them. And most of the hires we make come through that funnel rather than us like an application page or like. It's tough though. It's like we haven't made a hire in months for that reason. It's super tough to find the right people.
Thank you.
Yeah.
How many do you have now?
7 right now. We need like 11.
No, you didn't have your hand up. Next, you're the one that had your hand up next. In the mask.
Me?
Yeah.
Yeah. I mean, can I ask a question?
Yeah, go for it. Tell me.
Yeah, so I feel like there seems to be like not a lot of redundancy in the pipe system. So like, what is y'all's contingency plan for like, let's say there's a crash down there or something, you have to reroute everything. Like, how much would that impact delivery times, or like, what would your maintenance plan be for that?
Yeah. So when it comes to failure, we've overspec'd everything. So like, there shouldn't be a failure. Kind of like airports where like you can't have that plane fail. So just like overspec, like a safety factor of like 4 or 5x. Because like the weight doesn't matter to us, cost really doesn't matter to us when it comes to the robot. So you can really overspec that bot and make sure it's really robust. So there's 2 failure modes. One is the more common like electrical failure or really bespoke like comms failure or like oopsie, robot doesn't want to go anymore, who knows what. And so what we've made sure is that when we're designing the system, it can't fail in a way that it locks movement. So the idea is that if there's a non-catastrophic failure, another robot can come and just push it to the next extraction point where it can just be pulled out of the system from there. Because it's like, you're right, like the name of the game is uptime, especially because like we are locked to this system. We have no, like if this is blocked, you've got to go all the way around and that kills the system. So the idea is like, you want to make sure you get that one out. The other one that we've yet to run into, but we have a pretty small sample size, is the catastrophic, where it's like, boom, it's like broken and like it's not moving because it's in a million pieces. That one, we have like a really high torque bot that we'll make, and it will just like bulldoze all the parts through. And then in really extreme examples of that, the way that it's handled in utility is through these services. I saw one today, but they have like these high pressure systems, and they pop into one of the sides of it. They usually use it for like sewage drains, and they pop one on one side, one on the other side, and basically just like create this really strong vacuum, and they flush the whole network. So on extreme examples, those services already exist for utilities to be mobilized in 24 hours. So we'll use one of those, which will also be how we solve flooding. This is a nice thing about borrowing from like decades of utility experience is like a lot of those like really odd problems have, there's already a support system for it.
That makes sense. That's really cool. I guess one more question about like the pipe system. Maybe kind of naive of me, but it seems like you can't really scale up like the cars in the pipe model too much, because like at some point you'll have too much of a delivery volume and you'll run out of like cars, or there'll be like a traffic jam in the pipe.
Yeah.
What's y'all's contingency plan for if and when you get to that kind of scale?
Yeah, I need like a whiteboard. Okay, so imagine there's a whiteboard here. So these pipes, the algorithm that you want to hit here is, we call it flow rate. So it's like at any point, like call it this point right here, how many cars can go through that at a time. And you want to like take a point all over the network and you say, okay, what is the weakest point? And then that's your flow rate on the network, like whatever that is. And so for us, it's probably going to be like a 4-way turnstile. So the whole system is designed to hit this minimum amount of flow. And it's like, how do you decide your minimum amount of flow, right? The way that we've defined it is you want it high enough that half of that number, this maybe gets a little confusing, half of that number, you are making so much money off of that expanding the network is like an obvious, like you definitely have money from a per month basis to like add an additional lanes. So that number for us is $7.50 an hour through the biggest choke point. Because once you start hitting that, you have the money to expand capacity. So you just want to make sure that you're never caught in a position where you are choking and also aren't making enough money to expand. So that is probably like, we'll see if that number's right. It definitely could use a few more looks, but that's how we think about it.
Who pays you for what?
When you like look at these networks, the financial model is based on no one paying for anything, so we would just cover the cost of it. So whether that's equity financing, but more likely there are infrastructure financing groups that when you like build out utility systems like railroads, they take over those assets. So they're like designed to hold those assets for 30 years. So it's like a really defined type of infrastructure purchasing. We are assuming we won't have access to those. It does look like we will, but we're kind of built the whole financial model around what if we just have to equity finance this and build each one out of the profits from the last one. And then if you look at the long tail of infrastructure for projects like these, open sourcing the technology, allowing anyone in a city to build those assets and own them, and then we would power them and do a rev share with the person owning that, has been the way that those type of networks scale, like railroads and fiber optics, and people can find really unique ways to kind of like, why do I want to call him Paul Rudd?
Ross Perot?
Ross Perot, yeah. Like they find those creative ways to install the network. So we'll do that. That's like a long-term thing. But for now, we've built the whole model around us, just finding it ourselves.
How much money have you raised so far?
We've raised a little over 6.5.
All right, keep going down the road.
Okay, so y'all are an infrastructure company, first and foremost. And from this like extremely ambitious plan to expand this minimum viable network, you're gonna be ripping up a lot of roads very quickly within a single year. Like, or I assume that's from like for the picture, you cut a hole in roads and stuff.
Yeah.
And like, I already have heard so many complaints from people around Austin of, oh, it's driving takes so long and everything.
Yeah.
And from like the expansion aspect, you have to keep putting things in if you expand it. So how are you dealing with public perception? Like how do you make, you're dealing with municipal governments and municipal laws. How do you make sure you don't get choked by regulation before you can even
100%.
create stuff?
So you can kind of see it here. It's not really a good picture, But at no point during the installation of this, and this is like, we went with the cheapest option, which is just trenching, where you cut a hole in the ground, because we had the option to here. So the name of the game is like, permitting is really easy until you mess up traffic. So at no point during this installation will we mess up traffic. We're along the sides of the roads, we're in that utility easement layer that sits next to roads. And then when you're going through a parking lot, you've probably driven over them. There's a way to like cut and cover. So you do an initial cut, and then you cover it with a metal plate, and then you like when you go and fix it, you like stitch it up. So that's the method we're using here. You mind if I hop onto your browser, or do you want to?
You do.
Okay. Oh, sweet, perfect. So in places where that's not an option, what you use is a horizontal directional drill. And you've probably seen these, especially like downtown. You've probably seen these and not know what they are. But there's definitely like, and we definitely dealt with this when we were looking at it initially, is like there's this dancing bear problem with utility where if it interrupts traffic, you're like, oh my gosh, utility interrupting traffic again. But you don't realize how much utility goes in the ground without disrupting traffic. There's usually like, we use HDP, it's very like pliable and movable. Usually when you're cutting up the road and stopping traffic, you're using like steel pipe, something that is like very rigid and has to be dropped in. It can't be pulled through. So the way that horizontal directional drills work is there are these, let's see.
Oh, that's right.
Oh, yeah. So I don't know if you've ever seen these, but they come in kind of like non-invasive surgery. They come in at an angle, and then they do a big, it's not very big. They do a big drill one way, come out of the ground, and then they take a bigger head and they'll increase the size of that hole, and then you pull the pipe through that way. So you can do that for up to 2 miles through there. And so that's where, like, if you can't cut and cover along the side of the road and you have to go under the road, you can just do a directional drill. It's a little more expensive, but it's not much more.
Okay, thank you.
Yeah.
That totally answers it.
I really don't like that picture.
Okay, so I have like kind of a general question, but
Yeah.
kind of, what would you say a lot of people get wrong about building a startup, or that like you think of that's different, and what is one thing that you think of that's like the same?
Yeah. I think I'm very on the hardware side. Like hardware startups are like pretty tough, and I'm still like learning a lot. So I'd hate to like tell anyone anything on that side. But end of the day, having like you were saying, like having a hypothesis and testing it really quickly, no matter what you're doing, is the right way to go. So many people don't accomplish a startup because either they run out of steam, or they never take a first step. They have a process and they never try it. So the best entrepreneurs I've seen are people who have an idea, they find a quick way to test it, and they're like maniacs about how quickly can I test this. Something we brought on a lot of founders on the team, so we have we ship software products every once in a while. I love Bubble. That's how I build all my software products, and so we have this is not a flex, but just as an example, we have a game that gets anywhere between like 100K and 40K daily active users on it. That we built on Bubble in 2 hours. So we did it in 2 hours. We did have to spend like an extra like hour later on to like, because it just got a little too big and it was crashed. We had to do an hour of optimization. But between those 3 hours, maybe call it 4 or 5 hours into the day, we've never touched it again. So like Bubble, I think no code gets this idea of like it's not real code. In here I don't know if you guys have seen it.
Not a flex, not a flex.
No, we got super lucky. We got incredibly lucky. But it's this no-code solution where you can build web apps really quickly. So we can turn around like a Twitter clone in like 6 to 8 hours with Bubble. It definitely has a learning curve, but even if you code, I really think it's the fastest way to build a demo of something. And so just like whether it's Bubble or like finding like, okay, or relieve yourself of like how you're going to build it or how you're going to do it or doing it the right way. Just find the way that gets to as close to that MVP as you want and just like go test it quickly as possible. I think that's always the right answer, no matter what you're doing. Oh, it was called Fractal.
So you guys generally just, and then now how much money is it making?
It makes like 10 to 15K a month.
What?
Okay.
Yeah,
Would you recommend that we create games on our own?
I would not recommend a game. It was, the way that it happened was we finished a board meeting, we're like, okay, let's think of like, what's the biggest arbitrage opportunity right now? It was like during the Wordle craze. We're like, oh, like those kind of new kind of games are really hot. Like what's a version of that we could build? And then Marvelous Mrs. Maisel just came out, and it's like the only show that I like. And there's like 2 episodes, so I had like 2 hours to watch the episode. I was like, okay, I'm just gonna build, this Wordle variant, which is like, it's like trivia. It's like Wordle but for trivia. Let's see. So instead of like 5 letters, there's a question, and then you're trying to think, okay, top 5 types of artists, professions in the United States. That's another good question. We're gonna get that one figured out. But then you have all these options, and you're like, okay, photographers, writers, authors, street artists, theater. We are also gonna lock in those ads, but it does. We did the checks do cash. I guess that is why it turns out it does pretty good. And so you get like green and yellow. That is really funny. So the way, what we don't want to do, this is actually a great example. So I will talk to this person. But we built the company to run autonomously because like we can't waste bandwidth on something that's not like our core function. So the idea was, can we rev share with like 2 to 3 groups? And so we have someone who does growth, we have someone who manages questions in the community, and then we have someone who manages ads. And he does do a good job. Our ad rates are really good. So his 2 KPIs, and I'm gonna add looking at the app to this KPI because like that is so many ads. But his 2 KPIs is like, okay, don't reduce player rates. So like, don't make people drop. There's so many ads that people drop off. It's been strong. I don't know why. Definitely need to scale that one back. And then also like, what are your ad rates per 1,000? So like, how good are your ad rates? So like, what programs can you use into? And then put as many ads as you can get to maximize the money you pull out without killing playership rates. And then we just like, that's all we look at. We meet with them like once a month, and then it's like we can run that and not have to think about it. So that's a really long answer to your question.
Really fascinating.
Yeah. And then we'll, that is so many ads. That is a ridiculous amount of ads. They do make a good amount of money though. Yikes.
All right, let's keep the questions flowing.
Hi, Garrett. On a podcast, you mentioned something about that we just kind of like own things out of convenience.
Mm-hmm.
And you were talking about how Pipe could help reduce that need to own and kind of share resources. An example you use was a screwdriver. But I was wondering in the conversation, have you go more in depth about like why would people decide to share, I guess, something as simple as a screwdriver when the convenience of what if they really need the screwdriver now, but then they have to wait because someone else is using the community screwdriver. How would that
Oh, sure. Great question. So, I think the comp that we use is like, there's always, there's 2 types of ownership. There are things you actually do want to own because they have like some sentimental value for you. Or it's like a high cost item, or it's like a very personal, like it's like earphones. Like I want my earphones, that's my earwax. I don't want like a mix of earwax. So outside of those, I think there's always been this knee-jerk reaction to increased speed of delivery of things. And there's also been this overreaction on how much people want to own things. I think a good example is probably like, even like a library is a good example. Like maybe there's some books you want to own, but if you had like more access to a library, you don't actually want to own that stuff. Or like iTunes. Like my mom, to this day, will buy songs on iTunes because she's like, I don't want to stream music. I want to own that song. But like, I don't think any of us, does anyone own like songs on iTunes? Yeah, it's streaming it is so much better because like you want to maximize your usage of an asset. So if you can point and click and have a song play for you without having to buy that whole song, not only does your cost you spend on that song go down, actually the amount of money you spend per month on music goes up. So it distributes to more people. Like this has like all these crazy network effects. Same thing with content. Same thing with like Amazon. People are like 2-day delivery. That's crazy. No one needs things in 2 days. Who needs something shipped in 2 days? And now it's like, gosh, it's gonna deliver tomorrow. Like I need it today. And so like it's not as much sharing economy, right? It's not like I don't think hyperlogistics creates like it's like, oh, very nice, like we want to share with people. It's more about convenience. Like I don't necessarily want to buy this huge tool collection. I'd much rather have a tool subscription, and as long as I can rely on tool delivery to hit at a certain delivery time, just like we do with Netflix. I know if I point and click at a movie, it's going to deliver it to me, so I don't need to go rent it, right? As long as you can hit those delivery times really quickly in that like sub 10 minute, the cost of the delivery that's really cheap, and you have a way to return it really easily. I think that is just a natural like interaction that people would really love. It's a bet, could be wrong, but I think like the long tail of history of like commerce says speed and friction reduction trumps ownership always. But there's obviously like at some point there's gonna be into that. So we'll see. I don't know if it's true. It's definitely a theory. And I truly believe like I don't know if we'll crack it, but someone's gonna crack it, and whoever cracks it is gonna make so much money and have like such a positive impact on the world. So yeah.
So I worked in supply chain optimization for Amazon this past
Oh,
summer.
heck yeah.
Yeah, and one of like you mentioned that you have like middle mile technology. I know that's something that Amazon's like really interested in right now. But for Amazon to like really use this, they like the big thing they want is like hard guarantees on deliveries, and to also be able to like scale as needed to like meet their capacity needs. So I was wondering like if Amazon like, theoretically were to use this, how could those needs be met, and like kind of would they own the the network, or would you like work with them, or?
I think it depends. I think so. They is this recorded?
No,
Oh, beautiful. Awesome.
not by us.
Oh, gotcha. Oh, yeah. You guys can record it. I don't know. So they had a project called Amazon Highway. I don't know if it was like kind of under the radar, but there's you know what a PR FAQ is? A PR announcement and FAQ on the bottom. Isn't there a book that like we all read it when we started Pipe Dream? It's a book of like how Amazon operates. It's really good. I think if you guys are gonna read like something about how companies operate, it's so good. But like the PR FAQ is like it's a PR page of like PR announcement of this new product, and then an FAQ page of like how it actually be used. So Amazon Highway was an underground system that they were working on for a while. I think they ultimately decided not to go with it for antitrust reasons, because there's like an Amazon pipe underground. Like you're owning like physical infrastructure. That's very antitrusty. But someone from their team cleared the PR FAQ for us as like a helpful tool. So we have all that data on like the things, like the sizing limits, and it's so helpful because like those sizing limits help us determine like how to maximize cargo volume and minimize pipes, like get that like really locked in. But also like what kind of flow do you need in between like what places. So that was really helpful. And so when it comes to like big e-commerce, that's the document that we lean on the most. Yeah. I'd love to talk about your time at Amazon though.
Oh yeah, definitely. If you're free, like after, we can definitely chat.
Oh, that'd be awesome.
Yeah, thank you so much.
Yeah.
What is PR FAQ?
So it stands for like a PR. What's the best way to describe it? It's like a PR announcement. So if this is like Alexa, it'd be like the front page would be a PR announcement. It'd be like Amazon. It's like a way to pitch something internally. It's like a project.
Oh,
so before. Yeah. So if I would like to take something. Do you want to explain it?
Oh yeah. So like it's basically like you have like a press release, right, where you like pitch things internally. It's like before you even like start the projects and everything. You kind of have like the press release like as if like you already have it, and then you talk about how this is going to improve operations or how it's going to improve the business overall. And it's something you kind of like send out to internal stakeholders and kind of like get their review on things and just let them know it's coming. Just kind of keep everyone up to date on that.
It's a cool document.
Yeah, I had to write one. So, yeah.
All right, third row. Got anybody?
Oh, nice.
So I guess I had 3 questions, 2 of which were kind of related to like technical implementation things since we've been asking those, and one of which is a little more enjoyable, I guess. I guess I'll ask that one first. So I guess you've probably heard of Hyperloop, so I'm interested to get your thoughts on that. As in, like, I know everybody kind of bashes the economic feasibility of this, and as you mentioned, like you kind of try to fight that with your kind of loading the costs more towards the vehicle itself. But I'd be just kind of interested to get your thoughts on like the feasibility of this system and this technology behind it.
Oh, Hyperloop?
Yeah.
Yeah, for cargo, I think the way we thought about building the system, and the nice thing about Hyperloop, we definitely have a, I don't really have a good picture. That's close. Okay. So that's a pipe. Imagine this is enclosed, right? And what you have in front of here is like a big mass of air, right? Like air's pretty heavy when it has nowhere to go. I can do this, like bat like air around, but it's like it's not because air is easy to move, it's because it has places to go. Here, it has nowhere to go but either this way or try to go around the bodies it's coming through. And because we're not pulling a vacuum on the system, it's basically pushing that air. And so there's 2 ways to solve it. One is you pull a vacuum on the system, and that is so expensive and very delicate, right? So it means that,
Like a syringe. Like holding a syringe.
Yeah. So you have to be so airtight, and it's very tough to get utility pipes airtight. You have to custom coat them. They're pretty porous. The fusing thing that you have to do to connect them, you can't use because that will leak air. So it's really expensive to pull a vacuum. So pulling a vacuum is not feasible economically. You can pull a turbofan through it and compress the air and pull it through the machine, which is the sexiest way to do it. And I really want to do it that way because it just sounds so cool. But we've discovered that the best thing to do is just add capacity to the motors to just push the mass of air, which is it's not an elegant solution and it's not fun, but it's by far the cheapest. And like I was saying, you don't really get penalized for bigger motors in this system. So bigger motors, bigger batteries, and based on our fluid dynamic simulations, which I don't know, a simulation's doomed to succeed is one of my favorite sayings. So we'll see. But based on our most critical simulations, that's gonna be the best. So Hyperloop definitely gets around that. Pulling a vacuum on a system and then doing maglev and or even just a linear motor, you can go way faster. So when you're trying to compete with jets for people, I think it's a great system at the cost of a really high infrastructure cost to install. So I think it was just we have different variables. This is a very engineering heavy question, and apologies, but we just had different variables going into the system that precluded us from doing a vacuum at all.
What is the average size and weight of the bot?
It fluctuates. I think it just went up. I think 110 right now kilograms.
Okay.
So it's not trivial, but it basically is compared to other inputs.
All right, we've got time for maybe 2 more questions, so make them good.
These are awesome questions, by the way.
Yeah.
I'm really surprised. Oh, I don't.
What would you say is the energy efficiency
Oh, it's
Could you repeat the question?
Oh yeah. So the question was, what is the energy efficiency of pipe dream versus what we have now. Pipe dream is like, it's like dumb energy efficient, but I think like it's so ridiculously energy efficient. Unless you're counting, like there is some. It depends like what you want. Like, are you looking at like cost of energy, or are you looking at like for energy from an environmental standpoint? Yeah, either way, it's like really reduced per delivery, right? It's like basically nothing. It's like a fraction of a cent per delivery, and like we're doing batteries now, which definitely have like a, we really need to reduce our reliance on lithium, so we'll put it on a grid eventually. But it's like really, compared to what we're doing now, we haven't even bothered to calculate it. Maybe we should. There is a carbon release when you're digging up dirt. That's not huge, but it's not trivial either. So we're gonna offset that. But like on a per delivery basis, it's pretty good. I don't know what it is.
It's worth noting that COE, cost of energy, is as important in startups like this as LTV and CAC, right? Because anytime you've got a high energy usage product, it really factors into your unit economics. But for those of you interested in climate tech.
I have a really short question. So I heard you say earlier you raised 6.5 funding. So I just wanted to what you did.
Oh, what I did to get that?
6.5
million or billion?
Oh, yeah, 6.5 million. Yeah. I'd be really impressed if it's like 6.5 thousand. We should win an award. It's 6.5 million. So we haven't touched a lot of that. We raised 1.5 like a year ago, and worked out of, I don't know if I have a picture of the shed. We worked out of a shed in my backyard that when I moved to Austin, they condemned. It was not like, it was held together by like 2 2x4s. So like we were like super, I didn't take a salary for a while, my competitor didn't take a salary for a while, like we were super like, I think we hit our goals and spent like 500 to 600 of that 1.5. And then we just raised a new $4.5 million round.
What was your first round?
1.5.
Are you willing to talk valuation? Like, what's the valuation metrics in this kind of market?
Yeah, super tough. There's like, we try to, maybe a little too like, I definitely messed it up to begin with. And I don't feel qualified to give advice here. When we started, I was trying to raise like a $2 million valuation, and that was a lot harder. It was like, we could not do it, and then I didn't know what I was doing. And then when we raised it to 8, which is what we initially raised on, it became a lot easier. So I think like, I'm a very like Southern boy, like I don't want to like over like value myself. But I think I learned now like you're as much danger undervaluing yourself as you are overvaluing. So just trying to like figure out a price that makes sense for everyone, and is a price that makes people take you seriously. It is the real name of the game when it comes to valuation, when there's not like a comp. And if you have a comp, then it's a comp and it's in a spreadsheet. But like for us, like we don't have any revenue yet, so like getting that valuation done is super tough. So what we have done in the past that has worked for us is just getting commits without the valuation. Something what's the name from Techstars talks about?
Bradfeld?
Not Bradfeld.
Jason Seeds?
I am totally blanking on the name.
Uncapped note? Is that what you're talking about?
No. So the idea is, I wish uncapped note would be great. The idea is like you get a commit contingent on finding a valuation, because that valuation is tough to find. You say, are you interested? If we get to a valuation that you can agree upon, you can get all those commits, and then once you arrive at an evaluation with like a lead or someone else, go back and tell everyone what the valuation is, and they close at a pretty high percentage if it's like a reasonable valuation.
Yeah.
Because it's tough to get that narrowed in. It's super, especially now when it's no one knows what anything should be valued at all. But ours was we did $1 million at $8 million, $500,000 at 12, and then this round was at 40. What's that? 40 million, yeah.
The carbon emissions from the process of establishing your infrastructure, does that come from the vehicles involved, or is that like, I don't know, carbon sinks with the landscape?
Yeah, I'm not sure. It's like there's a way that you can calculate it where, like, if you and I'm out of my element here. There's a way you can calculate it, like if you turn over X amount of dirt, it releases X amount of carbon. And I'm not sure what is happening there, but there is like an equation to calculate it. Does anyone know like what's happening there?
I do not.
I don't either.
It's probably like impervious cover, so, you know, certain amount of, yeah, that makes sense.
It's just like a little
It's
bit, it's not
carbon.
that much. Yeah.
It's the ratio of beetles to soil.
Yeah.
And the release of the methane gas from the beetle exoskeleton.
It's the beetle parts. Yeah.
You heard it here. Beetle parts. All right, Garrett, thank you so
Yeah.
much. Let's give him a big round of applause. Super interesting, and wishing you lots of success.
Oh, thank you.
And
We need a lot of luck.
Way to go for your pipe dream.
Yeah.
All right, I
Appreciate
think we're gonna put up the QR code, and we'll call it a wrap tonight. Next week you've got DoorDash, Open Door, sorry, thank you. All right, thanks y'all, thanks for letting me come, and happy to give you the Front Gate founder story some other time.
Thank you. Thank you.
I used to teach a class.
Oh,
Yeah, Josh
Valuation.
and I taught.
It's on that desk in the front, that looks like a robot.
So you're already here now?
There's like a little path.
Where's your grade?
We were in
Just like stuff like supply chain. Yeah. They're doing like this homework. That's like it's really cool.
Well, I started my first one in a enclosed garage.
Yeah.
So
Oh, nice. Oh, very
Like you said.
Awesome. It's good to meet you. Hey, Garrett, great question.
Oh, I see you, bro.
Yeah. Oh, heck yes. Yeah, so the tough part of link switching, which I'm sure you know, is like there's two good ways to do it. Or there's really like one good way to do it. It is to stop, put it on a turnstile and turn. But that kills your flow.
Oh yeah, fish.
So what we're trying to do.
Yo, Nathan,
75 miles an hour.
the fish.
250 is like a theoretical resulting flow issue. Yeah, so the engines, the motors are spec for like,
Yeah, bro.
they're like, don't go as fast as we want. The problem is like, how do you control your
Hey, we're gonna do a social at a nice place.
This one's your flow.
Oh, that's
75 is like a full range.
Armel, by the way, we gotta do a social at, you know Dan? He used
So
to be
what
a
we
tech
did is we
department.
put
He's my roommate now. We
rails
live on
like
Rainy
a turnstile.
No one's gonna be
If every turnstile has
It would be awesome, but
ability
like
to
no one's
make
gonna, it's gonna be like 5 dudes.
with a solid rail. So then the bond can hit the rail, transfer on, and then it's that turn full speed, and then you switch the turnstile for the next one.
So basically, we set
Yeah, and then it's static when the time is there. There's so many problems with that model. They're like problems the other problems.
Yeah. What he said. Yeah. I mean, if you could do it. I know, but I mean, like, that's just it's like, okay, guys, I'm start.
If we can manage
Yeah, that's how I felt. It's just like I'm like, you know, it's just like randomly talking
So
about
if
stuff.
we can, we'll do
I have
like
no idea,
full
like, this
flow,
guy's super
One Direction.
Instant 200 million
valuation
Yeah.
for polychain, bro.
Polychain. Dude, it's always polychain. Every time.
That's
Yeah.
I actually said the only thing that matters is like actually getting shit. Like getting shit.
Yeah, but you still you've lost that pot. You gotta get back, right? So if it's gonna do an NP run, it's gotta do an NP run somehow. Yeah.
Yeah.
You wanna jump in? Okay. Alright. Yeah. We can pull G's and so like is like your term radius for like how many G's you pull?
Yeah, and then like professors making things like that. Yeah, but it's still like.
Yeah.
I was gonna ask you about the security. Bro, this guy's like,
bro, like
Max just leans over there. He's like, this seems like Max says, this seems like a good way to like hurt a boss. I'm like,
we have like a standard curve.
I mean, I'm just being like realistic. Like,
you
even
want
when
to
you
go
don't
jump in and take like a really
Even like you could just cut the pipe and then think about all the stuff you pick up all the rollers.
But how would you get into it though?
like a turn. So
Yeah,
you're
you're gonna get caught.
make a turn.
You may as well just like
and then go
like raid the post office. There's gonna be like enough places to where it's like.
no, so that's where we're a little better. We can kind of take an angry turn. You gotta slow down, but you can pull a couple G's.
Travel and shit.
You can handle a couple G's.
That's so true.
Yeah, I think it'd probably be like not like open to like anyone to just drop stuff in. I think it'd be like it's gonna be like in the target, and you know, or like yeah, or like people like the nodes.
I mean, let's say you can like return stuff.
Yeah, so, I mean, like, how I presume is that it's like